Hello, I'm Alban. I'm 12 years old. I'm from Indonesia. My project is a binary tree parser for arithmetic, Boolean, binary, and string expressions. It's basically like a calculator, but with some cool additions like multiplying and concatenating strings, or adding strings together, and variables, and binary operations, and Boolean operations, and equality operations. My project is written in C. What it does is take an expression in text, lexer, parse it, and then execute it. This project also has operator precedence, so multiplication and division gets executed first. Then other arithmetic operations and all binary operations, equality operations, and then Boolean operations. This project supports arithmetic operations, string operations, binary operations, Boolean operations, equality operations, and this project also supports variables. You can create variables using the equals operator. You can assign to a variable while doing an operation on it. For example, v plus equals 1 will add 1 to the variable v, and it is equals to v equals v plus 1. You can also replace the plus with something else, and then it will be equals to v equals v operator 1, and operator first and replace operator refers to the replaced plus. I chose this. I chose to create this project because one of my programming dreams is to make a programming language, and I think this will be my first step into doing so. Okay, now let's take a look at my program. So in here, there's the lexer, there's the binary tree, there's the executor. Yeah, that. And if I run this, we're gonna compare. We're gonna try executing this arithmetic expressions in here, and check if the tree is equal to this. So now we're gonna try this Python here, and this expression equals the result in -13. So we're just gonna play my project and see if the tree is equals. So first there's a minus. There's a minus. At first there's a minus, and then there's gonna be a divide, and then there's gonna be an add, right? Minus, a divide on the left, and then a plus on the right. So on divide, it's gonna be a mole on the left, and then an add on the right. A mole on the left, a mole on the left, and then an add on the right. And then on the left, there's gonna be a token add, and then it's gonna be 3 and 1. Token add 3 1, and then it's still gonna be a 3 in the mole here, and then add, there's still gonna be minus 59 and 5, and plus with 2. Right. So after that, what I found difficult while making my project is I think the parser, which is basically most of the program. It's the hardest thing in here. Thinking about how to implement the operator precedence was hard. And because this is C, freeing the binary tree without extra allocations is also pretty hard for me. I personally think it's weird if the function that destroys the binary tree can fail. It's meant to destroy. It shouldn't fail because the system doesn't have enough RAM to allocate a stack for the DFS. Uh, is there anything you will do differently or you will add if you had more time? Well, I'd say I'd definitely finish this project if I had more time. But because I was out of time, then I'm just gonna say that I am going to recreate this whole thing. And here are the things that I will improve on the remake. And I am going to remake this because the design was once bad. First, the way I implement the overall precedence, I'm gonna improve that on the remake. And also in the way I allocated each of the parser nodes. Each nodes have their own data. Their data can contain 8 bytes or 24 bytes of memory. 8 bytes until 24 bytes. It can include be 16 bytes, depending on the type of node. The way I allocated it is that I allocated the biggest data size. This was done so that it will be indexable on an array. But in here, the node is never used for an array. It is only used for a tree. Every tree's node is allocated dynamically so as a variable. So the array indexable thing is useless and is not needed. So the thing is wasting a lot of memory. And here, the lexer is also separated from the parser. And the lex data is placed on a dynamic array that doubles its size when it's full. And I actually ran a test with a file that has 1,000,000 plus characters, and the program uses 500 megabytes of RAM. And when I checked, the lexer has allocated 500 megabytes of memory and only around 250 of that is used. Well, the parser uses, well, a lot less than that. So in the recreated version, I will not separate the parser from the lexer, or just making the lexer be a token by token generator instead of something that generates an array from an input. So yeah, that's it for me. Thank you.